Hi, everyone. Today, what we're going to do is we're going to walk through a very similar investigation that we did a few days ago when we reintroduced our basic trig curves, or our primary trig curves. So, if you take a look at that page in front of you, it should look somewhat familiar. What we're going to do is we're going to go through now and we're going to examine this for all of our reciprocal trig curves. So, you'll notice the very first one that we're going to deal with, we're going to address our cosecant. So to do that, let's go back to what its primary graph would be. And so we should all be good that cosecant is the same thing, or the reciprocal, I should say, of our sine curve. So what you'll notice in the table is I've already gone through and filled in all those key values for our sine curve. And those were the exact same values that we hid out last time when we reintroduced our sine curve. For us to go through and see all of those values and to know that cosecant is the reciprocal of sine, then for us to go through, what we're really addressing then is taking the reciprocal of all of those sine values to come up with the exact value of cosecant. And so for us to go through, we would then see that the reciprocal of 0 would be 1 over 0. And we know that that's going to cause a problem. And when I calculate 1 divided by 0, I'm going to get an undefined value. And so I'm just going to put a little slash there, just as we did when we introduced our tan curve. We know it's undefined. If we were then to work through, take the reciprocal of 1/2 is 2, take the reciprocal of root 3 over 2, which would be 2 over root 3, reciprocal of 1 is 1, and so on and so on. And so as we find the reciprocal of each one of those values, those will be exact for us. But if we were going to go through and graph them, we may want some decimal approximates to be able to estimate. And so if we were to go through then and final, then really the only value that we may need to push buttons on, or would need to push buttons on, would be a decimal approximate for 2 over root 3. And that is approximately equal to 1.15. And so everything else, we know the exact of. And there is our completed table of values for cosecant. So what I'd like you to do then is to go through relatively quickly, and let's take that table, and we're going to take the blue value, and we're going to go through and graph. Now, what I would like you to do, and if you have some colors, this is very useful. I would argue to you, if you don't have colors, don't do this. But if you have multiple colors, then let's go ahead and put on a quick a quick graph of our sine curve. So I know my sine curve starts in the middle and rises, and we should have this one down pat as we go. We're going to talk a little bit about a comparison between these two, but we're going to leave a breakdown of that comparison as we move forward. So what I would then like you to do is to go through and plot all your points for cosecant. Okay, pause the video now. Go ahead and do that. Okay, so we're back. So as we went through, hopefully we were good to be able to go through and say pi by 6, we have a point at 2. At pi by 3, I'm 1 and a bit. I'm 1 and a bit, 2, -2, -1 and a bit, and so on and so on. Those points should have been pretty automatic for us. But also, the fact that we know the reciprocal of 0 would be something like 1 over 0, that we should then have asymptotes at 0, at pi, and at 2 pi. And if we have that as our picture, then I think we should be pretty comfortable to be able to deal with this and deal with this. I think we should actually be comfortable to complete the entire graph, but I want to stop and I want to talk for a second about what's going to happen in this interval between, ooh, yikes, I got a little wide there, between 0 and pi by 6. So, if you take a look at your sine curve and we think about the reciprocal, then we should understand why what we naturally want to do occurs. I'm hoping that we want to take that blue curve and then make it approach the asymptote, and so that that would feel natural for us. I'm hoping that that's the case. But for us to address then, why does that happen? I want us to take a look at our red graph. Notice that at this first point on our red graph, we have a very small y-coordinate. Like, let's even say, estimate it, that it would be about 0.25. Well, if I was then to take 1 over 0.25 for us to find the reciprocal, then that would be 1 divided by a quarter, that equals 4. Which would mean that for this very small sine value, when I take the reciprocal, I get a very large cosecant value. And so we should get a little confirmation then that as my sine value gets bigger, I would then on the reciprocal be dividing by a larger number, which would then proceed to give me a smaller number. And it's that relationship that then says that our cosecant graph should take off in that direction. Now we should be able to move a little quicker as we kind of go. My sine curve starts to get really small as I approach pi. So look on your sine curve, and as we start to approach pi, my value of sine gets really small, so its reciprocal gets really big. We get to the other side of pi, and you have a very small number. It just happens to be a negative. So when you take the reciprocal of a really small negative number, you get a very large negative number. And then same thing on the other side as we approach 2 pi. And so if we were just to take a look at that blue graph, you now have your graph of cosecant from 0 to 2 pi. Now, as you take a look at it, a couple things that should jump out at us. We've got some asymptotes, and we have what we can see as 2 branches of our cosecant graph. We'll notice that they tend to look like little parabolas in each of those areas. They look like parabolas because they're symmetrical. And so what we have then are our branches of our cosecant graph. Now, what I'd like you to do is to extend this graph back down to negative 2 pi. And the way that we're going to get really good at graphing our cosecant graph is to always relate it back to our sine graph, because we know our sine graph really well. So, a couple things that I wanted to make sure we were good at. Let's focus in on the key values of our sine curve, because I think those key values of your sine curve should be in your back pocket, and they're going to help us to create our cosecant graph. So, first thing, where does my sine curve begin? Well, it begins at the origin. And so, if it begins at the origin, it begins at 0. And so if I take the reciprocal of 0, then I get an asymptote. Okay. Now let's go back to my next key value. My key value, my max on my sine graph is at pi by 2. My maximum on my sine curve becomes a minimum on my cosecant. Okay, let's look at the next. I have a 0 at pi. If I take the reciprocal of 0, I get undefined. There's my asymptote. I take a look then at my minimum. My minimum on my sine graph is at 3 pi by 2. So when I take the reciprocal, then I get a maximum on my cosecant. And then I come back to my last 0, and if I take the reciprocal of 0, I get an undefined value. Therefore, asymptote. And so, as we start to work our way through that, we can work backwards. So, I know that my sine curve would hit a minimum at negative pi by 2, which means I'm going to have a maximum on my cosecant. My sine curve would come back and hit a 0 at negative pi. That means that I have an asymptote at negative pi. My sine curve would go and hit a maximum at negative 3 pi by 2. That means that I have a minimum on my cosecant graph. And I would hit a 0 at negative 2 pi. And if I take the reciprocal of 0, then I have my asymptote. Just with that information, my guess is you could probably create a pretty good graph, and we wouldn't need to focus in on our 2's, our pi by 6's, to get the shape. I think if you said, well, I know that I have to approach that asymptote, and I have to approach that asymptote, and I really just try to make a well-rounded curve, then you can get pretty close at times. I want you to notice this value should have gone through 2. I'm really close. Okay, over here I was off, but I still get a pretty decent curve. So if we make sure that our curve is well-rounded, and all I'm going to do is just get rid of that little minimum I drew, but if we make sure that it is well-rounded, then even just with a fast curve, I was almost bang on. So, the point I want to get when we have to go through and create our cosecant graph, we're going to want to be able to create, at the very least, this interval from 0 to 2 pi in about 20 seconds. We're going to get to the point where we have to transform this graph. Then for us to be able to work through, if we can relate everything back to our basic function, our primary one. So you should have your sine curve in your back pocket. Use your sine curve to go through and produce your cosecant using what you know about reciprocals. So there we go. Now what we're going to work our way through for the rest of this lesson is addressing our other 2 reciprocal ratios. So if you have that lesson page with you, what I want you to do is I want you to turn over that page, and I want you to jump in and start dealing with your cos curve and then your secant graph. Okay, get to it. And so as we take a peek, we should be good, that we know that the secant is our 1 over cos. And so you'll see the completed table that we did, just the same as what we did with dealing with our cosecant graph. Hopefully everything matches up with what you see on the grid or on the table. And now we should be good to be able to go through and produce our graph. So pause the video if you need to confirm your table. Otherwise, we're going to move down and look at our picture. Okay. And so as we progress and work our way through, we should be good to do the same thing with producing our picture. So what I'd like you to do is to go ahead and put on your coast curve, but just from 0 to 2 pi. And then plot your points for your secant graph and construct it the same way we did previously. Okay, pause the video now, go to it. Okay, we should be back. So we know that our coast curve starts at the top and falls. Connect with a smooth curve. A little wobbly there. And there we go. There is our coast graph. And so for us then to produce our cosecant, or sorry, our secant, we would now have these values. We know what those slashes mean, or more importantly, what those undefines mean. And then as we progress, and there's our points, and we should have been really solid then. Given what we did when talking about our cosecant graph, is that we should have been very comfortable to produce that blue curve. Okay, now let's go through and let's complete the bottom. So we're going to go through and we're going to continue that sketch of secant, but back to negative 2 pi. And we're going to use everything that we used in our background. So let's focus in on our coast graph. We know that if we continued back, our coast graph would have a 0 at negative pi by 2. And so if it's a 0, then the reciprocal of 0 gives me undefined. And so I have an asymptote. We would then know that we would come back and hit a minimum at negative pi, which means we have a maximum on our secant. We would then come up and hit a 0 at negative 3 pi by 2, which tells us that we have an asymptote. And we would then come back up and hit a max at negative 2 pi, which tells us we have a min. Okay, now we should be able to fill in knowing what we know about what each branch looks like. So, a decently rounded curve. Then we have to be nice and rounded, nice and rounded. Same thing here. And there is how we use our coast graph to generate our secant. Okay, so now we should have our cosecant and our secant graphs covered. We have to get really good at knowing those curves. And now it's time to introduce cotangent. Okay, and so as you flipped over that page and completed your table dealing with tangent and cotangent, we should have been good on our, that our cotangent is the reciprocal of our tangent. And so you see in red, there's all your tan values, and then you see in blue, there is us going through and dealing with our cotangent. So we had to push buttons on a couple things, the value of root 3, the value of 1 over root 3, and we should be good with our decimal approximates. So now that you've checked your table, what I want you to do is to go ahead and produce the graph. Now, my suggestion to you, because otherwise this is going to get really ugly even with multiple colors. Put on your tan curve, but do not graph your asymptotes. So, as you're going through to produce that picture, on that grid, put on your tan curve if you have multiple colors, but don't put on the asymptotes of your tan curve. It's just going to make it look really ugly when we then have to put our cotangent graph on as well. What I want you to do, though, is graph the full cotangent graph, so asymptotes and all. Okay, pause the video now, give that a shot. Graphing from 0 to 2 pi. Okay, we're back. Hopefully we have, in our background by now, our tan curve, and we're pretty solid to say I know my tan curve starts at 0 and then does that wavy thing. It hits our first asymptote at pi by 2, and we know at pi by 4, we go through at 1. And so there's the shape of our first wave. We then know we have another 0 at pi, another vertical asymptote, and then another 0. Now remember my instruction. It was don't include your asymptotes. So all you're going to see on my picture then is the wavy thing. I know that pi by 4 beforehand, I have to have a value at my -1. Pi by 4 after pi, I have to have a value at 1. And so I'm going to use those values to generate my shape, knowing that the asymptotes exist at pi by 2 and 3 pi by 2. So I'm approaching that value. I know the asymptotes are there. I'm just not drawing it. And so we get to that point, and we should be good on our tan graph. Okay, now we're going to plot the points and deal with our cotangent. So the first thing I notice is I have an asymptote, and we should be solid with that in our table. I then have a value at pi by 6 of like almost 1 3/4. I then have a value at pi by 3 of about 0.6, maybe about there. I then hit my 0. I then hit my -0.6, my -1.73, and I then have an asymptote. As soon as I get to the other side, I'm back up at 1.73, and now all of a sudden we can see the pattern in the remainder of our points. And as I finish at 2 pi, I have my last asymptote. And so we should be good then to be able to connect these points and connect these points. And given that we know our tan curve, we should be very good to finish off our cotangent graph. And there we go. Now, couple things that we should notice. That I should cross, first off, that wherever we had an asymptote on our tan curve, we now have a 0. Wherever we had a 0 on our previous curve, we now have an asymptote. And lastly, we can think of our 1s. I was a little off right there, but I was pretty solid on the other 3. Because when I take the reciprocal of 1 or -1, I still have the same value. And so we can actually see where our cotangent graph intersects our tan curve. Okay, couple key ideas as well. Notice that your tan graph was always rising. As we move left to right, your curve was always increasing. We notice that our cotangent graph is always decreasing. We have the same wavy feature. Okay, so now what we want to do is we want to be able to build it backwards. So, a couple key things then. I would know that my tan curve would continue its wavy thing until negative pi by 2. At which point, I would then have an asymptote on my tan graph. So, if I have an asymptote on that tan graph, then that means that I have a 0 on my cotangent graph. I would then hit my next 0 at negative pi, which means I have an asymptote on my cotangent. And I can continue working my way back on where would I have asymptotes, and therefore where would I have zeros, all the way back to negative 2 pi. Okay, I know that my cotangent graph always falls. And so if I go pi by 4 back, I would then have to be up at 1, pi by 4 forward at negative 1. That's how I'm going to get my decreasing curve. And so I can connect that using my shape of that wavy part and then approaching my asymptotes. So I can do the same thing, pi by 4 and 1 and 1. I don't like that last part. I didn't quite get to my 1. And there we go. There's your cotangent curve. Okay, our job now is to make those graphs as automatic for us as possible. Notice that I didn't really memorize anything other than I've got some asymptotes and I have some parabola-shaped branches for cosecant and secant. And then on my cotangent graph, I get the same wavy shape, it just decreases. If I can have that in my head as I work my way through, then everything else I'm going to use by building off of the primary curve. So if you know your sine curve, cos curve, tan curve well enough, then you have everything you need to build your reciprocal graphs each time. So what I want you to do now is to jump into the second video. It's a quick little conversation about how we compare our graphs. And the act of comparing our graphs will help us to understand our reciprocal curves.